Hello students, I am Dr. Sanjeev Ponia. In last lecture of computer graphics, we discussed about three-dimensional viewing and we saw that how we can represent a camera-driven object that is in 3D object in two-dimensional that is on view plane. As we discussed that we have to draw each and every object on 2D as on our output device. So for that we have to discuss about the projection. In last lecture we discussed that what's the projection. In this we will discuss about the projection in detail. Over here we will discuss about parallel projection in this lecture, and in coming lectures we will discuss about perspective projection, orthographic and oblique projection, and cavalier and cabinet projection. So first of all we see that what are the different type of projections. As we saw that projection is a technique by which we convert a 3D object in 2D, and this is a technique that is performed on coordinates, that is on pixels. So we will see all these things in detail after discussing the types of projections. So let's start the different type of projections. Basically, projection is divided into two categories. First one is perspective projection and second one is parallel projection. In perspective projections, all the rays are came from the single source or from a definite distance, whereas in the parallel projections all the rays are coming parallel to each other, that is from the infinite. Then perspective projection is of different three types, that is 1 point, 2 point and 3 point projections, that from where we are seeing the object from a single point, from a two vanishing point or from three vanishing point, that is using the 3 point projection. And in parallel projection these are also basic two type. First one is orthographic and second one is oblique projection. When we want to discuss about the orthographic projection, then orthographic projections is also divided into subcategories, and these are number one top view, number two front view, number three side view, and number four are axonometric, whereas this axonometric is also divided into three types, and these are isometric, diametric and trimetric. On the another side, oblique projection is also divided into two types, that is cavalier and cabinet projection. So this is the complete classification of a projection. In today's class, we will discuss about the perspective projection. So first, Again, we will try to understand that what's the projection and what's the basic difference between perspective and parallel projection. So, as we discussed in the last slide, that projection is our basic two type, that is perspective and parallel projection. So, we can divide projection in basically two type. First one is perspective and second one is parallel. So today we will discuss about the perspective projection. So first of all, we will understand that what's the difference between perspective and parallel projection. Then we will try to understand it with a example. In perspective projection, as I told you that COP, that is center of projection, is at a finite distance. Means all the projected rays are seem to become from that point, and in perspective projection it will look like a realistic look, as a person sees an original object in the daily life. So prospective projections is look realistic, and this is used in the computer graphics. We will discuss preserve relative ratio after the parallel projection. So, as I told you that in perspective projection, this is a realistic look, means the image looks like as we saw in our daily life, but in parallel it is not realistic look, as the rays came from the infinite point, and basically it is used in architecture and engineering drawing. In parallel projection, the preserved relative ratio of the image is maintained. Means when we have to take the image of an object on a plane, on a 2D plane, then size of that image will be equals to the size of the object. It means that the relative ratio of object as well as image is preserved, means constant. But in case of perspective projection, it is not the case, means the same size of object and image is not kept. The size of the image is going to be changed, either it is larger than the object or smaller than the object. It depends on the distance that from where we want to see the object. So the ratio depends on the object distance from the viewpoint. Now we will try to understand this with an example. In perspective projection, this is a object. Let me take this. This is a object. AB is a object, and this is our center of projection. This is our center of projection. From this point, the rays are going to be started. So these rays are going to be follow the path and it will strike at this point to the object. As I told you that image can be either in the back side or it can be in the front side. So here we are seeing a image of object AB, that is A dash B dash, in the front side. So the size of the image, that is A dash B dash, is less than size of the object. So you can see from here that the size of the object and image are not constant. If I want to see the image from here, then you can see like this, that the image size will also changed. So in this case, relative ratio of object and image is not preserved. In the case of the parallel, you can see with the example that the center of projection is at infinite. So this is the region that these waves, projected waves, are seems to come from infinity. And when these are came from infinity, then in that case they are parallel to each other, and the image of the object AB, that is A dash B dash, is of same size as AB. So in this case, ratio, that is relative ratio of object and image, is preserved, that is of same size. So this is the main difference between parallel and perspective projections. Now in the exam, they asked about the difference between parallel and perspective projection. There are two questions. One is based on parallel and perspective projection, and second, I will tell you when I will teach you the point that is inside parallel projection. So now, as these are two basic types of projection, so a question is always came based on this, that explain the difference between perspective as well as parallel projection. So on basic of some parameters, we can define that as in description, the lines of sight. The lines of sights are convergence, means center of projection is at definite distance. And over here in this, you can see that parallel projection is a projection of an object in three-dimensional object onto a fixed plane referred as projection plane or image plane, known as line of sight, or projection lines are parallel to each other in parallel projection, whereas this is not the case in perspective projection. When we want to discuss about the type, or we want to differentiate based on the type, then this is three type, that is 1 point, 2 point, and 3 point, as we discussed in the first slide. This is one type, second type, and this is second type, and this is the third type. So on base of classification, that is types, we can divide perspective projection in three types, that is 1 point perspective projection, 2 point perspective projection, and 3 point perspective projection. Whereas parallel projection can be divided basically or broadly in two types, that is orthographic projection and oblique projection. We can divide these again the subparts, but these are the two basic classification of parallel projection. Then about the ratio of object and image, that is accurate view of the object. The perspective projection cannot give the accurate view. As I told you that in this, the image depends on the object distance, and in this case, this provide the accurate view, that is the size of the object and image are constant, whereas in object representation, the perspective projection represents the object in three-dimensional way, and in parallel projection it will look like the telescope way, as a person is seeing the object from a definite distance. So these are some basic differences based on description, type, view, and object representation. On basis of realistic view of object, perspective projection forms a realistic picture of object, whereas in parallel projection, it does not form realistic view of the object, as the COP is on the infinite distance, and that is not possible in real life. Next, distance of the object from the center of projection. In this, the distance of object from the center of projection is finite. In this case, in the case of parallel, it is infinite. In case of perspective projection, projectors in perspective projection is not parallel to each other, whereas these are parallel to each other in parallel projection. In perspective projection, the ratio is not preserved, while in case of parallel projection, the ratio of image and object is preserved. And in this, the line of projection came from parallel. In this, the line of projections are parallel to each other, whereas in perspective, these are not parallel. So this is a important questions that generally comes in the exam. So you have to keep remember the difference between perspective and parallel projection based on description, type, view, object representation, distance, projection lines, and projectors, whatever. So these are differences between perspective and parallel projection. Now we will study different type of perspective projections, These can be divided in three types. First one is 1 point, second 2 point, and third one is 3 point perspective projection. In these, we have to understand the vanishing point, that a vanishing point is a point where all the projected lines are meet. When we want to see the image of an object and we send the projected lines, then the point at which all the lines are going to be meet. And principal vanishing points is a meeting point where all the lines are parallel to either x-axis, y-axis or z-axis. This is not in the case of axis, that the axis is either x-axis, y-axis or z-axis in the case of vanishing point, but in case of principal vanishing point, the axis is also going to considered. We will see this also through a diagram. So suppose this is a object, this is a object, and center of projection is over here. As we see that in this center of projection is at finite distance, so you can see that there is a finite distance between object and this center of projection. So you can see that this is looks like telescope view, as the rays are going to be start from here or are projected from here, and when we want to make the image of this object on 2D plane over here, then this is the image of this particular object. So this is looks like the images or the object we are seeing in our daily life, and the size of the image is based on the distance of COP from the object. So this is about the perspective projection. Now we will see an example of 1 point, 2 point, and 3 point perspective. When there is an object and we are seeing that object from a single point only, as this is the case, this is the home and we are seeing this home from one angle only, then it will look like this. When we are in our home and we are going to see it from one angle or from a point where we are, then it will look like this. But when we want to see first the object from this point and second object from this point and combine these two images, as this is a image, once a person see the image from here and second time the object is going to see from here, and then we are going to combine the image, then it will look like 2 point perspective in this case. And when it is 3 point perspective, then in that case it is going to see from the three direction, that is from the right, from the left, or and from the top. And after that we combine all these three different view to form a 3-point perspective. So this was about the differentiation of 1-point, 2-point, and 3-point perspective. I think now the prospective projections will be clear to you, as in projective this is in this the distance of the object from the COP is finite. You can see from here this example. Yes, you can see from this example that the COP is at a finite distance from the object. So this is a realistic view. These type of views we have to study in our computer graphics. So in next lecture, we will discuss about the parallel projection. So thank you. Thanks a lot for